Today we are going to continue in in Unit 12 with Lesson 2. And today we're talking about conditional probability. So go ahead and get a bell ringer paper and start off by doing the bell ringer. And just pick two people to go up to the board and pause the video when you're done. When you finish the problems, come back and resume the video and we'll go over them together. Okay, so this problem says that a spinner has 4 equal sections that are red, blue, green, and yellow. Find each probability for 2 spins. So the question is saying, we've got the spinner, and if I draw a picture of it, it's got 4 equal sections. There's red, blue, green, yellow. Doesn't matter what order they're in. They're equal. They're going to have the same probability. Find the probability for 2 spins. So what's the probability of getting blue and then getting blue again? So the probability of just getting blue, if they're all truly equal sections, the probability of getting blue is 1 in 4. All right? So then the probability of getting blue again, just because it landed on blue once doesn't mean that it lessens the chance. It's still a 1 in 4 chance. So what we're going to do is we're going to multiply them together. This is going all the way back to like Unit 1 from first semester, so this might be need a little bit of review. And what we're going to do is we're going to multiply them. And when we multiply them, we're going to say it's 1 over 16. So the chance of getting blue 2 times in a row is 1 in 16. For the second one, the probability of getting not yellow. Well, there are 1, 2, 3 options that are not yellow, so that's a 3 in 4 chance. And then the probability of getting green, that's a 1 in 4 chance. So we're going to multiply them again, so we're going to get 3 out of 16. If you don't remember how to do that, that's fine. It's supposed to be a little bit of a refresher. Talk to each other if you have questions, and then when you're ready to move on, go ahead and hit play. All right, so today we're talking about conditional probability. Conditional probability is when there's an existing condition that could limit the supply space for an event. So we write it like this. It's like this P parenthesis B with a straight line through it, A. And we read it like this: the probability of event B given A. So an example could be like probability of getting an A given that you currently have a B. So it's saying, what's this probability if we know that this condition exists? And that's what conditional probability is. So let's just jump right in. So we're going to look at a lot of problems that have tables with them. But this one says the table to the right shows the results of a class survey. Find the following probabilities. Did you do a household chore last night? So they've got yes and no, and then they've got male and female. So if we look all together, first thing we should always do is see how many people did they interview or did they ask. So if we add straight across here, we've got 15. If we add straight across here, we've got 13. So it should be 28 total. I usually use this diagonal line like this just to show that that's the total. And I can double check that. If I add vertically, I should get 14. And if I add vertically here, I should get 14. So those still add up to 28. So what's the probability that if I ask one random person, what's the probability that the person is male given that they did do a chore? So what I'm going to do is say, all right, let me look at my male category, but I also need to look at my yes category. So I know that this is true. So I'm only looking at the people who did the yes, answered the yes category. There are only 14 options to choose from there. So I'm going to say out of 14, what's the probability that the person is male? Well, in that, I'm going to say there are 7 males who said yes. So really, if I simplify that, I would get 1/2. If I said, what's the probability that the person is, or that the person did not do a chore given that they are female? So looking at this row right here, I know that they're female, that this is true. What's the probability that they did not do a chore? Out of 13 possible females, only 6 said no, so I would be a 6 out of 13. But that can't simplify, so that would be our final choice, or final answer. What's the probability that the person is female given that they did not do a chore? Okay, so now I'm looking at this column. I know that this is what's true, so I'm looking at that column. There are 14 people in that column. And what's the probability that they're female? There are 6 people in that column. So it'd be 6 out of 14. Divide by 2, simplify a little further, and we get 3 out of 7. And finally, what's the probability that the person did do a chore given that they're male? So now I'm looking at this row. I know that this is what's true. They're a male. How many males are there? There are 15 males. And how many did do a chore? 7. So I would take 7 out of 15. So it's important to know, I check my how many are there total to make sure that I'm doing my adding correct, but I'm always going to add up the rows over here and the columns down here so that I can quickly and easily find my denominator, 14, 13, 14, and 15. When you're doing conditional probability, we are not actually using this. That is just a good check to make sure that we're doing our math correctly in adding. All right, so there's a little bit of an easier way because there's not always going to be a table. So if we're asked to find conditional probability, we say, what's the probability of both things happening? And we divide that by the probability of the given statement. Probability of both things happening divided by the probability of the given. So let's look at this. If it says if 80% of an airline's flights depart on schedule, 72% of its flights depart and arrive on schedule, find the probability that a flight that departs on time also arrives on time. So this is our given. We're given that 80% of an airline's flights depart on schedule. We're told, this is our and, 72% of its flights depart and arrive on schedule. So they're asking us, what's the probability that a flight departs on time? That departs on time, sorry, arrives on time. Probability that it arrives on time given that it arrives on time. Guys, they're not going to tell us every single time in these words. They're not going to say, find the probability that it arrives on time given that it departs. I put arrives, I meant departs, sorry. You have to be able to figure this out for yourself. So if we're reading this, this is what's given. So that's what needs to go right here. This has that magical word and, so I know that that's going to be my P of A and B. We'll call this B and we'll call this A. So P of B happening, what's the probability that it arrives on time? Given that it departs on time, is going to be P of A and B over P of A. So what I'm going to do is plug in these, but I'm not going to use 72%. I'm going to write it as a decimal. So I'm going to say my probability of the and is 0.72. My probability, or my given, is the 80%, so that's 0.8. And now this one I am going to put in the calculator because we don't want to have a decimal, well, 2 decimals, especially within a fraction. So if we do 0.72 divided by 0.8, we should get 0.9. So we could say there's a 90% chance the flight arrives on time. There you go. All right. Final problem. Sometimes we're going to be asked to make things look organized in a visual way. So make a tree diagram. And a tree diagram, it's going to look something like this, where we're going to start from one assumption, and then we're going to keep breaking off branches. So the easiest way I think is just to kind of jump right in. So it says, in Indianapolis, a teacher made the following observations. About 22% of all students never fail a math test. Okay? So there's 2 options right away. Either they fail a math test or they don't fail. I know which category I'd fit in. I I'd fit in the fail. But anyway, so 22% never fail. So that's a 0.22. Well, if they don't fail, that means that they failed. And if we say, okay, if 22% have never failed, then that means that 78% have failed at some point. The way I get this is because it has to add up to 100. So if I do 100 minus 22, I'm going to get 78. And that's how I'm getting that 78 right there. Then it says after failing a test, so I'm looking at this branch right here, students study harder for their next math test 61% of the time. So if they have failed, they have two options. They can either study harder or not study harder. Study, no study. And it says that they do study harder 61% of the time. So that's a 0.61. But if I look at 100 minus 61, I'm saying that means that 39% of the time they don't study harder. So 0.39. And then finally, it says after passing a test or not failing a test, students study harder for their next math test 13% of the time. So they say, I passed, I don't need to study harder. So our number there is going to be much different. So study, no study. And it is important to label these. You can't just put numbers on there, the 0.22 and 0.78, and expect people to know what you're talking about. So they study harder 0.13% of the time. And if we do our 100 minus 13, we're going to get 87. So that means that 87% of the time, they are not studying harder. Or they're studying the same or less. So that's just kind of a basic intro to conditional probability. Here is your homework. Go ahead and start working on that in class. Bring your homework to class tomorrow. We'll look at it together. And if you have any questions tomorrow when I'm back, we can go over it together. Thanks, guys. Have a great day.